to look at two results in today's video which help us manipulate series, and the first one is essentially to do with a sequence only converges if and only if the latter terms converge. So that is that if the sequence converges, that implies the latter terms converge, and if the latter terms converge, that implies the whole series converges. And we can figure this out, or prove this quite simply. We know that if we take the sum, let's just formally rewrite this result. So if we have P and Q and Z, where Q is greater than P, then AK, where the K's are greater than P, is a real sequence. Then the sum of AK from K equals P to infinity converges if and only if the sum from K equals Q to infinity of AK converges. So what we're going to consider is the sum from K equals to P up to Q minus 1. Okay, well, this is some partial sum, so finite numbers of AK, so this is equal to some constant. Okay, it's equal to some real number. Doesn't matter what P and Q are, because they're defined to be integers. Okay, so they're not, Q minus 1 is not infinity. And if we take Sn is equal to the sum from n from K equals P, K equals P up to n of AK, and Tn is equal to the sum from K equals Q up to n of AK. So you can see that Sn is the same as this here, but with n not as infinity, and K is equal to Q, and Tn is equal to this one here, but again n is not equal to infinity. We're now going to consider Sn is clearly equal to whatever this constant is plus Tn. Okay, so as we raise, we can see now from this equation that if we take the limit as Sn, the partial sums, goes to infinity, that is only going to converge, and if this converges, it means that this top result converges if this Tn converges. Okay, because if Tn went up to infinity, well, we'd have a constant plus infinity taking the limits, and then we can just subtract the constant from both sides and consider when Tn converges, and that's only when Sn converges. So we get this if and only if relationship, which means these two statements imply each other. Okay, next we're going to look at adding convergent sequences. So suppose that the sum from K equals P to infinity of some real sequence AK, and the sum from K equals P to infinity of some real sequence BK converge. Then we want to let alpha and beta be real numbers. Then we have this rule for adding them. Then the sum from K equals P to infinity of alpha AK plus beta BK converges and is equal to alpha, the sum from K equals P to infinity AK, plus beta, the sum from K equals P to infinity of BK. And this is analogous to our algebra of limits for sequences. Okay, so if these converge and we've got some real numbers and we multiply our sequences by real numbers and add them together, it's equal to the real number multiplied by the sequence plus the other real number multiplied by the other sequence. Okay, and this is an intuitive result. You know, we might expect this to happen, but nothing can be assumed, especially with infinite series, because you can get some odd results, but it does so happen that this is the case. We won't consider a proof here, but this is the nice result to remember. So essentially, we can, if these two sequences are convergent, that's important. We can do this as similar with algebra of limits. If a sequence diverges, we can't use the algebra of limits on it. So it's the same here. These have to be convergent, and have real numbers here, and then we can apply this result. That's it on this video on manipulating series. If you do have any questions, let me know down in the comments. If you did enjoy this video, please help me out by liking and subscribing to the channel, and I hope to see you in the next.